Hi everyone, this is Satish Hooli. Today we are going to see a design on rapid sand filter. Thing here to be remember here is we are taking some peak demand over here. Okay, first you need to calculate and water demand, and that demand has to be calculated hourly basis. Okay, and why we have taken this as an this one assuming an average daily demand, because see, we have seen in variation demand, right? With the time there will be a variation in flow. So we can't design it for that flow. We have to design it for an average demand. Okay. So that is the reason why we have taken this one. Okay, you can refer in that variation demand chapter itself. Okay. So this is a problem. So what it states. So you have to design in approximate dimension of a set of rapid gravity filters for treated water required to be an population of 50,000. Okay, you are designing for a population of 50,000. The rate of supply being 180 liters per day per person itself. Okay. Next, it's nothing but it's in per capita demand itself. Next, the filter are okay. The filter are treated to work at 50,000 liters per hour. So rate of filtration here is nothing but it's in 50,000, sorry, it's in 5,000 liters per hour per square meter, assuming the necessary data. Okay, so you need to, based on this, you need to design an rapid sand gravity filter. So what are the given things? They have given a population of 50,000. Okay, so there is a rate of this one rate of filtration is around 5,000 liters per hour. Okay, per capita demand is around 180 liters, okay, per person. That is nothing but 180 liters per day per person. It is per capita demand itself. Now we will start up with the problem. So what we are going to here is we are going to write a note like key, assuming that the given rate of supply is an average demand, and assuming that maximum daily demand is 1.8 times. Okay, so it is nothing but in terms of peak it goes around 1.8 times. Okay, and average daily demand. So by using this one we are going to calculate it. Okay, so first step what we are going to do is we are going to calculate how much quantity of water is being needed per day itself. Okay, so 50,000, so that can be calculated by population into maximum daily rate of supply. So population is nothing but it's in 50,000, and 1.8 is nothing but you have assumed that average daily demand itself, that will be 1.8 times. Okay, so into the rate of supply, so it is 180, so that has been given here. Okay, so we'll get a value around 16.2 into 10 raised to 6 liters. So that is nothing but 16.2 million liters. This much of water being supplied daily. This has to be converted into an hourly, okay, demand itself, because your rate of filtration, it has been given in terms of liters per hour itself. Okay, now what we need to do, so this demand divided by 24 itself. Okay, so that will get you in terms of what, 675 into 10 raised to 3 liters per hour itself. So you have converted this one into what, an hourly basis demand. Now what he has said, we have to take we have, this already has been given, like filtration rate is 5,000 liters per hour per square meter. So now by using those two things what you are doing to do here is you are going to design a bed for filter. So area of the filter bed required equals to what? Is nothing but it is water demand divided by rate of filtration. So that is nothing but 675 into 10 raised to 3 divided by 5000. So you will get around 135 square meters. So since we are keeping, we need to design two set of unit, because in case of one being broke down or one being taken for serviceability like cleaning and all, the other should run. Okay, there should not be an interruption of water supply. So we need to design it for two set. Okay. So now taking 2 units into consideration, what they have done is they have divided 135 divided by 2. So that will be around 67.5 square meters. Okay. Now by using this equation, okay, so L equals to 1.5 times the B. Okay, by using this one, so now uh, we have rewritten that equation like 1.5 square equals to 67.5. Okay, so here the b square is equal to 45, b equals to 6.75. okay, now you got a width, you got the length. Okay, so this is our dimensions and we have to consider it for 2 units. Okay, by considering in 2 units. Okay, so this is all about rapid sand filter. We are going for another set of problem over here. So what he has stated here is design a rapid sand filter unit for 4 million liters per day of supply with all its principal components. Okay, so what he has given? He has given 4 million liters. In here, what we are doing here is we are assuming it. Okay, what we are assuming in this problem here is we are assuming it 4% of the water may be required for backwashing. So considering that, what we are doing is for calculation part, total water required for per day equals to 1.04 into 4. So this will be how much? 4.116 million liters per day. Okay. Again, what we are considering in this problem is it is also similar to the previous one, but some changes were here. Okay, so what they are considering here is they are assuming 0.5 hours is the loss every day in washing. So what they are thinking that is in this one you are taking out your filtration unit every day half an hour for cleaning purpose. Okay, so rate of filtration per hour is nothing but here what will be happening is 4.16 million liters divided by 23.5. So this much amount of water, filtered water, is required per hour. So that will be 0.177 million liters per hour. Okay. Now again you are calculating here length and breadth also. Okay. So assuming the length as 1.5 times the width of the filter bed, that's P, and for 2 beds. Okay. So total area are provided as, okay, so 2 into L into P, directly they have taken it, okay, equals to 35.4. So what is this 35.4? 35.4 is nothing but the area itself. So it is being calculated by this way. So it is nothing but assuming the rate of filtration is around 5000 liters per hour. So you have seen here this one. Okay, so it is nothing but water required, filtered water required per hour. So that is being divided by 5000. So you get the total bed area. So that is 35.4 meters square. So you are taken this one here itself. Calculated here the breadth. Next, you need to calculate the length. Therefore, length equals to what? L equals to 1.5 the times the B. So 1.5 into 35.43, that has been previously calculated. So we'll get 5.14. So we can round up to around 5.2. Okay. Now using that same thing, the length, you are calculating the breadth over here. So that is 5.2, which has been calculated previously. Okay, you are considering that. So P equals to how much? 35.4 divided by 2 into 5.2. Okay, so you'll get the answer like B equals to 3.4 meters. So this has been also adopted for 2 units. So dimensions will be, so you have a length of 5.2 meters and the breadth of 3.4 meters. Okay, so this is all about design of rapid sand filter. Okay, thank you very much.